Okay, so today I have a big plan on making the fonts work. That means I will have my texture buffer in the on the GPU. So like, let's say this is a square buffer, right? And then I draw all of my characters, A, B, C, D, E, etc., right? And then when I reach the end, like let's say this is K, I wrap around to the next line and I keep track of what is the highest one character. And I want to have also a, should I have one pixel is probably enough between characters. Just one space, one pixel buffer space between characters, just to make sure that there are not just to make sure that they are not actually influencing each other if something is right on the edge. Like you can imagine you have E here, right? And right there you have D, not even like that, but like here would be D. And they are touching. And then when I'm drawing this, I have the E, but then it has this extra line right where the D is intersecting because the alpha is screwed up or something like that, right? So that's what I'm going to avoid. I think 1 pixel is enough. Also, I was reading about the buffer itself because I wanted to initially just have a buffer like that where I write all of the characters. Yeah. Write all the characters in a big line all the way to the end. So like this would be, 9-0 or something like that. But apparently that doesn't really work because the GPUs are optimized for squares, or maybe not even squares, but like not hugely wide or tall textures. And because of buffers, the way buffers work, even if I'm having like a small buffer like that, it might be like doubling it just because it needs to have some kind of like extra space, or like everything needs to be aligned in a certain way. So I am not 100% sure what the maximum texture would be. I don't want to make it too large though. So I'm not sure if I should like just go through all the characters once and calculate, okay, what is the total area that these occupy? And then I decide, should it be a 10 by like 1024 by 1024, or should it be 496 by 496? It kind of depends on the font size. Um, But the issue would be like, let's say I take something that is too big, then I just have a bunch of wasted pixels for no reason. That's not good. But if it's too small, I might start drawing to the buffer, and then I reach the end. So yeah, A, B, C, and then D would be here, and oh, I ran out of space, and then I have to scrap everything and I have to redraw it in a larger size. Like I could do that, but then that doesn't seem like such a smart move. Um, so now, if let's say how do I make this? There we go. Let's say that this is one character. Then I add 1 pixel on each side as an alpha. Here's another character. It might be smaller, alpha. And then I just do that for every character. And then I calculate the area of that. Then I would get I would get the minimum, like the perfect arrangement of them. However that would look like. It would tell me that it definitely doesn't fit in some minimum size, but it might fit in some larger size. Because if I would just do this with different characters, right? If I start on the next line, you notice all this is wasted space because I have a character that looks like this. It doesn't go into, like, this is just wasted space. And I could try to like fit it in this slot right there, but realistically, it will be just much easier to say, okay, this is this entire line is spent, and then we start doing the same with the next line, right? So if we consider this one line, there might also be, you know, some space at the end, because this character might be too wide for that. So if you add all this up, I would say it's pretty reasonable to assume that whatever space the characters themselves take, the actual space they will take on the in the buffer is probably going to be around double. So then I can get an estimate on like the minimum size buffer that I need. But it might not still be enough. Then that means I would have to do the thing that I said, you know, just start over from the beginning and make one larger. Now, that is like the nuclear option. That's the thing I need to do if it literally doesn't fit. Just start over. And, you know, that would be fine if it happens so rarely because I'm having this, you know, I'm making this assumption that I'm calculating the space I need, doubling that, and then assuming that's probably going to be fine. If it's not fine, then, you know, tough luck. But it's an edge case. But it's something I would need to implement just to be sure that it's not going to be messed up anywhere. Then the question is, of course, can I not make this larger again? Ah, here we go. Then, of course, if I have a 1024, I have a buffer that's 1024 by 1024. If it doesn't fit, yes, I can do 2048 by 2048, but is that really necessary? Because that's a quadrupling in size. Does it make sense to do that instead? Then I don't even have to re-render the characters I already drawn. I can just add them below. I might have to copy the entire buffer to a different thing. Or actually, there is this one trick where I allocate a size, but I only claim it. What is this called? Not allocate. So on Windows, at least on Windows, you can request a size of addressable space. It can be almost as large as you want, like, you know, 500 gigabytes, 1 terabyte, whatever. That's fine. Hey, Lake. What's up? But yeah, addressable space. Let me show you that. So Win32 virtual alloc, I think it is called. So virtual alloc is really nice because it has the allocation type. And the allocation type says commit, reserve, and yeah, basically that. So what you can do is you can reserve, say, 1 terabyte, and then you can commit just what you need, 10 megabytes. And then you realize, oh, I need more memory. So you double your memory requirement to 20 megabytes. You commit that as well. You keep the pointer. The data is in the same space. The address is still in the same space, and it's like continuous. But you don't have to copy. You don't have to copy anything. So that's a very nice way of dealing with memory in Windows. Now, I'm not sure if this is standard int or standard lib. I don't know if you can do the same thing in here. I believe it's possible. I just never tried it. You were doing very similar things. Nice. What are you doing? Because what this is, well, it's not much to show right now, but in case you saw it, or in case you didn't see it, I have my Windows application, right, with a window. I'm rendering fonts right now. But what I can do, I can also compile the same source. Well, okay, it's a little bit different because probably the scale is different. But I can build the same source for the web. So everything I'm making is kind of like cross-platform, and I haven't started doing it yet, but I want to support Linux also. Linux is not going to be difficult because it's basically just the same code as Emscripten, except I need to support Wayland or X11, you know, something like that. But yeah, so I do wonder, I have to check this out. Standard lib h. What was this called again? Reserve. Because I want to avoid using the Windows stuff so it can be cross-platform if possible. I can have 2 versions, one specific in Windows. Probably it's the one that people would be using anyway. And there are like malloc is just a wrapper around the Windows virtual alloc anyway, I believe, on Windows. But if I can use the standard lib instead, it's going to be easier to have a cross-platform. So mmap, no, this is not. Yeah, virtual alloc, but I want to do it in with standard lib functions. Yeah, so realloc specifically, as far as I know, it creates a new pointer and copies all of the data from one pointer to the other, and then decommits. Maybe I'm not 100% sure if you have to free it yourself, because I don't really use standard lib that much. But obviously, okay, for 10 megabytes, like that's nothing. Like who cares? You can just copy it and that's fine. But if you have like if you have the option to just reserve, 1 terabyte of continuous address space, and then you allocate as much as you need. Of course, the allocation later can fail if you like start having multiple gigabytes and suddenly you run out of memory. Okay, fine, whatever. But if you don't know if you need 1 megabyte or 10 megabyte or 100 megabytes, but you are pretty sure that it's going to be within the limits of this system, then it's just the perfect solution, because it's basically like having this, like in C++, it's like having this I don't even remember what they're called, like these dynamic arrays stuff. It's like having that, but without the performance penalty. Well, the address space is virtual anyway, so like Windows, like it's not necessarily continuous in the physical memory in the computer, but the address space that you are using, that you're exposed to in your application, that is continuous and going from one address to the next. So one nice thing to do, for example, when you're using virtual alloc, is that you can request, okay, I want to have a pointer starting exactly at 1 terabyte. And then you get back a pointer that is like 0x1000000, like 15 times, right? And then anything that you allocate on top of that, like let's say this is your entire memory for the application, then you can do the like classical console thing of like, okay, I have all of my game state between 0x100 and 0x400, and then I have, you know, the texture data at 0x1000 to 0x5000, and you know, so on. So you can just look at an address and know what it is. And that's a virtual pointer, so you don't actually, it's not actually the like 1 terabyte location in your computer, but it looks like that to you because it's virtual and it's continuous. So that's kind of how it works. Can I use a standard lib to reserve and I'll later allocate memory similar to virtual alloc on Windows or Win32? I cannot. Okay. Fair enough. Like, fair. For this specific, like, I don't really need it to be, like, I don't really need it right now. So it's not a huge issue. Like I said, I could make one system for Windows and another for the other systems, and then the other systems just have to do the copy. And, you know, sucks for them, but whatever. But I'm not really interested in that right now. Like, this is going to be just a very simple thing. So I can think about that later. What I want to do right now is what I was talking about with this. So what the first thing I need to do is I need to have the alphabet that I want to use. My idea is, like, let's say we are having multiple languages in the future. So I have my English translation, and then I have, you know, my text, you know, the quick brown fox, blah, blah, blah. I can have some compilation script that reads all of the text in the entire thing, like in all of the files. And it counts, like every time it encounters a new character, it can put that into a buffer. So, well, this is a like funny example because all of them are, okay, it's not necessarily unique. Like here it will be THEQUICKBROWN but then O already exists. So then you add X and, you know, the other characters, right? And then you get like your alphabet. So even though, you know, some characters exist in the English language, let's see, what is a good one? Like, okay, like this is a good one, like the at symbol. So the font might support at, and it might be part of the character set, but maybe it's never used in the game or in the application at all. So then we just don't include it because like why would we? Similarly, if we have like German translation, we can just have we do the same thing. So we're like we have der Haus ist blau, blah blah blah, and then we do the same thing D E R. And notice also that maybe this is maybe we have some capital letters, some smaller letters. Maybe some letters are not there in one version, but they are in another. Maybe there's some italics, right? So like all of these things, you just put them into a buffer, and then you create the alphabet that you need, and then you put that into a list, add it to the game. It's a texture. You generate the texture based on that, and there you go. That's not what I'm going to do right now. That's what I would like to do in the future. Instead, what I will be doing is I would just type out the characters that I want. So in main, yeah, I'm going to use Sean Barrett's true type. So I'm just using this because it's very simple. And I don't need so much. Like it's just very simple. The fonts are not that complicated. I'm not planning on supporting that many different things. This I don't think works with Arabic and Chinese and Japanese and things like that. Or maybe it does, but like it only works for a subset, or you have glitches or something like that. Again, right now I'm only focusing on like German, maybe no English, maybe German, maybe Polish, maybe Swedish, or like maybe Spanish. Like I don't know, something that it would be very very simple to translate. Simply because I want to have the system in place for doing different translations, but I don't care too much about the implementation right now. Then you can't use it. Well, I mean, I think it supports Cyrillic. I believe. You need Japanese for sure. Okay. Well, I mean, it might work. You have to look it up. There's another library. I was talking about it before. KB font something. Yeah, KB library header. This thing? Yes. So KB text shape. I haven't used this myself, but this supports like everything, and it's like a 4,000. How many lines of code? Like 40,000. 30,000 lines of code, single include, and with this allows you to do anything. So that's what I would be looking at using. I don't know if he's rendering the font itself. So it might be that you can render using this one, each character, but then you use this to actually place it. Because, like the issue with Arabic and some other languages is that they have these, the exact character that you're using might change depending on the other characters, or they are modifiers to existing characters. Japanese is not like that, I think. So in Japanese, you have your basically one character is one symbol. Like of course the way the Japanese actually is, it's like you have a character that you modify, and that's the true meaning of it. But in terms of how it's implemented on the computer, I think it's just a unique character. But yeah. Enough about that. This is what I'm doing right now. I'm just like, I have my code point and then I render it and then I create my texture, and that's what you see right here. But what I need to do instead is I need to have my entire alphabet. So this would be A, B, C, D, E, F, G, H, J, I. In English, this is hard. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, X, Y, Z. And then same for small characters: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, X, Y, Z. And then numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Colon, semicolon, dot, comma, slash, question mark, exclamation mark, equal, plus, like, I'm not really sure anymore. Ampersand, caret, percent. And this is the thing, like, do I need $sign? Do I need euro sign? Maybe. Did I forget W? Ah, yes, you are right. That's fine for now. Now, the problem is if I use a character later, it's going to freak out and be like, hey, I don't know what you're talking about. And then I have to add it to the alphabet instead of just like scanning ahead. But yeah. For testing, I think that's fine for now. So then we need to do a loop. So I32 len. And now, am I going to use standard? Here I don't have to use it. I can just do size of alphabet. But that includes the zero terminator, I think. And then we do a for I32I equals 0. That's genius. Well, it's the thing. This is not a function. This is a macro in the compiler. So when you say size of alphabet, it just takes it knows the size of this because it's allocating it into memory right there. But like that's a compiler thing. It does so like what the compiler does, it's just it takes this thing, counts how many bytes it is, and then just replaces that with a number. Yeah, if alphabet would be not an array but a pointer, then it would be the size of the pointer, which would be 4 bytes. And that's the thing, because like arrays are not pointers and pointers are not arrays. You have to, they are very similar in many ways, but the array, especially for the compiler, always has the context of the full size. Like the compiler knows the full size of the array. So they are different. Right. Alphabet. So what we need to do, we need to first figure out, well, I need another array. I need a struct actually. So in main, We are having a character. So it will have all these things. Obviously, we have the... so should it be a char or should it be like U16 maybe? I think W cars may be better. At least for the character itself. Like, I think that's the smartest thing. Because otherwise I'm very limited in the characters I can represent with this struct. Yeah. So that's a character. I want to have a... And here's another thing. Because this is a macro in the compiler, I can do a character cars size of alphabet, and that's valid. So it doesn't matter what I type in here, like it will always be adjusted because it's like defined right there. If this would not be defined right there, I would need to have another, I would need to define the size as a const somewhere. But yeah, all this is gone. So this is now as C off, C offset. Scale. That's I think because I might want to have multiple alphabets. And that would have the font height. Like I don't need. I just need to have something for every character here. 0. The null terminator is not a character. Like I'm not even sure right now if I need that -1. I might not. I have to double check it. It's like this kind of like off by 1 error I want to avoid. I will double check it. Typically, when it comes to this, you don't really care if it's like 1 too big. You would rather have it 1 too big than to have the issue of like I guess you would notice anyway. Like doesn't matter. That's the answer. Right. Scale. So I wanted to create this alphabet. We're just doing it here right now. Elf. And that's also one of the reasons why I just because I was typing a lot of C++ before, also very simple things, C style C++, but like wow, the compilation speed between C and C++ is completely crazy, like multiple times faster. So like I just save that and immediately it knows the context, like within half a second. So that's the reason also why I wanted to try using C, pure C. Not that I'm a fan of C++ in general, but sometimes you have things like you want to have a namespace, so you use C++ even though you're writing mostly C code. Yeah, that's something that just made me very impressed. So anyway, Alf, he gets the font height or pixel height. You just use underscores instead of namespaces. I mean, fair. I don't really use namespaces either. Sometimes it's nicer just to make it an API that is nicer to use. But like, if you look here, like this is how this is my namespace, right? And that's how you do it in C. Like you create a unique prefix and just use that. There's absolutely nothing wrong with that. The only issue is that sometimes it can be a little, like if it's too specific, it can be a little bit annoying. And then a namespace can be nice just for using in a specific file, but it's not really necessary. Font. Maybe this would be better called font, but never mind for now. So I do all of that. I want to know the total area as well. Right. They are all integers, so I guess that could also be an integer. So I get that. So we do all that. We get the total area and double it. I don't really want to do that right now. That's going to create an issue. Like, I think it's just going to crash, so I can still compile it. Because I just want to inspect it. So like this is going to crash. Oh, no, it does something. It's using the texture that I created instead. Okay. Probably because the texture is the 0th. Like this is in the 0 slot instead when I'm binding it. So that's a good fallback. Anyway, main. We get a... Ay, ay, ay. So we get a total area something like 31,490. Now, if we have a 1024 by 1024, that's, you know, a factor 10 larger. So that's going to fit. 512 probably also fits it. 256 by 256. probably also fits it. So what we can do, oops, and that would not fit it, I think, no. So I think that we need to just like think of a formula. So we take that, square root it. I can't do that apparently. The total area was what? Just give me the 177, right? So how about this? $177. How do I get that down there? Like, let's take 178, right? We want to find this plus 1. Right? And we assume that is the one that we're going to use. So we have the total area. Largest bit set. Do I have that? Definitions. Bit. No. There's a way to, like, most systems have an intrinsic for highest bit. Yeah, Clangd using built-in CLZL intrinsic. So I can do that. Mm. Mm. 17? No. That's not. Oh, wait. That's probably true, actually. What was it? 3, 1. The 15th bit is set. So why is it telling me 17? The leading 0 bits. So like from the left, from here, like from here it's 17, I guess. It's 16 plus 1. Um, There's no inverse of that. Clear zeros. Pop count. Number of bits set. That's pretty good, actually. So it would be highest bit set equals this minus 32, which is size U32 times 8, right? And then we get the right answer, or am I off by one? Minus 15, of course. $15. That is correct, because this starts from 0. This 0th bit. So the 15th bit here is set. Which means that if this would be our value, this is the size of our side for the rectangle we want to use. Now, I want to take... what I actually want. And first, let's make that a macro. Does that take... it's a different one for U64. So U64 would be LL, right? Clear 0, long, long. Clear 0, long, yeah. And notice it says U here. It's not super important, but like, well, it can't be negative values. It doesn't have to be a unsigned integer, but it has to be non-negative, because then obviously this bit is set, and then you have an issue. I don't know how to make that work with this, but never mind. So I think that works. We can now get maybe like this. And this needs to be, again, I32. And the entire thing +1 afterwards. So that's a little bit complicated, but like what this is doing is get the square root of the total area side round it up and get the highest bit set to get the so here if the highest bit set here is the 7th bit, that's a 64. We want to have a texture that is 128 by 128, just to like make it one larger, right? So this is not actually the highest bit set. This is the area texture side length. If we shift this up by 1, this is not necessarily an integer, I guess. Oh. I think that's good. Okay. So let's just see how that works. You don't like it though. Ah. So it's a lot of steps in one, but I think this is going to be completely wrong. Of course, because this is the bits. I need to do, okay. +1, this +1 is different from this +1. This is rounding it up, and this is adding 1 to the final results. And this thing, this monstrosity of a this entire thing is the number of bits we need to shift this 1, 0B1. I don't even know if that's a feature. In C99, that's not a feature, I think. I was having an issue with that. Here, I think it's fine. So like we take 1 bit and we shift it up by this number, which is like, let me just step through the logic once more. So like if we find that this is the highest, if we find that this is some number, this is the highest bit, we find 1 bit above that. This is 128. This is our side, and then we take, this is the 8th bit, right? So then we take 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So maybe not +1. I guess we'll find out. Texture side length 256. So that is, again, this is our total area that we want to support after being doubled because of this thing that I was talking before. We take the square root of this, which was like 177, right? But you can notice this is a bit under. So actually what we're doing is we're taking 1 above just to round it up. This is a little bit above, right? Then We take we take this in binary. We find, oh, this is the 16th bit is what we want to have. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that too many? Because that's what I want to do, right? So it's 0B 1, 2, 3, 4, 5, 6, 7, 8, right? And then we shift it by 1 extra. So then we get this answer, which is what I wanted to find. Great. So we have this now. Which means that we need to allocate that. And then the channels for a texture is going to be 1. And then we allocate that. And then we can start rendering it. And the rendering process is going to be a loop. So for, and actually, speaking of loops, the alphabet here, you notice the 0 terminator is 78. The last character is 77. The size of alphabet, this alphabet length, is 78. So that's from 0 to 77. That's good. The chars, we can do this const. Yeah. Variable length array. It's not variable. Folding constant. What is this? Like that should work. It's the same thing. Why is it Wikipedia, Stack Overflow, Reddit, and JetBrains on the top instead of the like documentation? Uh-huh. I have never seen this error before. Or warning, rather. What are these results? Google is completely unusable. Do you see this thing? Like, I'm very, very specific. I want this, and like, this is not what I'm looking for. Anyway. A complex expression as a constant. I'm fine with it using a constant. Yes, it's compile time constant. That's why I used const. It can fold expressions. This code is non-portable. Uh, I mean, if that's the like, I don't even care. So let's just do this then. Like, doesn't make a huge difference to me, but okay. I thought it would be just legal because this is constant compile time constant, and this would be just this thing there. But okay. Anyway, maybe it's a C++ thing. What was I doing? I wanted to know if this was off by one. It's not off by one. So again, we use this alphabet length. For another loop here. Again, we take the character. This is the alphabet. No, it wasn't this. Mm-hmm. Actually, I need to tell it where it's going. Because right now, all of them will go into the very top left corner. And then this width. This is the width and height. Width, height, stride. Times channels. And then we get the scale. Yeah. I think it's drawing from the top left. Oh, what? Okay, the first is font info, then the output. Okay, so the output was the bitmap. It's right there. We're drawing there. Then, based on the size, we have to move the pointer to the right. And possibly move it down. So, if the largest height smaller than the character height, and the character height is this thing. And don't worry about this being calculated for every character. usually it's actually faster to calculate something than retrieving it from memory if it's too large. So having this and calculating the actual width and height is typically faster, or at least like about the same, than just like calculating it once and storing it, because it's just such a simple operation. Like this might even literally be free. It depends on the code around it. Usually things like this, the compiler or the CPU can like sneak them in to like between other operations. So yeah, don't be scared that this is like calculating something all the time. The largest height, if it's smaller than the height, then largest height equals the height. And then the draw point is going to be plus equals the width times the channels, right? Until we reach the point where the next one is gonna not fit. Or no, we have to check that. So if, well, I can't. This is where actually I might want to have. Might actually be nicer to just have that, because then I can go over by one here. So I can say if chars I plus 1 dot well, size x minus what was it? Offset. This is going to be 0 because this is not initialized for the last one in the array. So that's fine for the last character in the alphabet. But it will. I don't have to do extra checking in the meantime. So next width. If, well, I need to know what is my position in the array, or what is my x position that I'm trying to draw to, because maybe the first one is fine, the first row, but then I advance into the in the buffer a few lines down, but I need to keep. I start from the x offset, right? Like this is what I'm thinking about. So we start here in the very top left corner. We draw our first character. This is our first character, second character, third character, and so on. Yeah. And all the time, like, we don't really care about the exposition of all of these. Then we reach here, we realize, oh, we will be overflowing. So we need to advance. So we go back to the original buffer. We advance by the lines. But what is this comparing to? Well, it's comparing to the width from the left. So that means I need to track that. X offsets. Bitmap X. plus equals the width, right? So if the next width if this together is larger equal to the largest, no, the side length. Also, remember I'm doing +1 here. And I'm starting at +1 also. Mm-hmm. If this happens here, we do the same thing, but we also add the largest height times the stride. I was using that, this thing. That times the stride. So this is starting 1 pixel off the left side plus the number of lines that occupies there, to get to, you know, the next line that is below everything else. And maybe again take this +1 just to give like a little bit of buffer. Let's see what monster we have created. Well, actually, there's I forget to do some things. We have to do the largest height equals 0 again. And this only happens if we are not executing this stuff. Okay, let's see how that looks like. I'm curious to see if it even runs. Well, I didn't actually bind the texture. That's great. Total width and total height is not the thing. Side length. Oh. It's not. Oh, something something was there. Okay. Wow. Okay. Okay. Let's try. We go to the game. Let's just do this as 1 scale. I don't really care. Let's go. X. That doesn't look promising, but let's see how the texture looks like in RenderDoc. Mm. Okay, here's our texture. It's 256 by 256. It looks like, wow. It looks like absolute nothing. Okay, I will take a look at that in a moment. First, I need to take a quick toilet break, so I'll be right back. All right, I am back. I don't know what's going on here, so let's take a look, right? Probably what's going on. Yeah. Look at that. Look at my. Do you see my mistake? I see my mistake. Where is my? Well, I have to close this first. I will fix this today also. Where are you? Is it not running? It is running. So where is it? Here. Is it done? I really need to fix that. Okay. It's working again. So yeah, if you saw my mistake, you're gonna see here I'm drawing to the bitmap, not the draw point. Big mistake. Uh, it doesn't like this function. Doesn't like my character. What is this alphabet I? It's a B. Okay. The draw point. So why are you stopping me? So let's see what's going on here. We have our character C. Here's our draw point. The total is correct. 256 times 256. The draw point is 1 bit or 1 byte off the start, which is good. What I want it to be. The width and the height, all good. Yep. The side length 256. Let me just double check this thing. STP true type. Renders into bitmap you provide. I pass in out W. Am I misunderstanding how this works? Like that is working or no? Let's just do it once. And then you see the A there. That's fine. Now I do it twice. And suddenly I'm having an issue. Access reading location. So what's the issue here? I'm drawing that. This is working fine. If the largest height is smaller than the height, then make it equal. Now it is. The draw point is the width plus equals the width times the channels. So this goes 18 pixels on. Because this is the next row. And then the next row and the next row. It's like 256 megabytes. 256 bytes in between each row. So that's our new draw point. Next width. It's the next size is 13. If the bitmap X plus next width, this also needs to be plus. This should just be like here. This bitmap X actually starts at 1. And otherwise, the draw point equals bitmap plus bitmap X. Yeah. Like that. That's better. So the bitmap X right now is 1. We add the width, which was 18 plus 1. So now we're at 20. The next width is 13. 20 plus 13 is still less than 256. So we get the draw point for the next. It's right there. Now we get the next character. It doesn't say the character, funnily enough, but okay. Yeah, the width was 13 and some height. And then it breaks. Why does it break? So the font is 0? No. Nothing changed about that. The draw point is valid. That is valid. That is valid. Stride, again valid. Scale, alphabet I. So I don't know why it would be not working. Format 4. See, the thing is, if I do this, that doesn't fail. Like, that just works. So it's specifically doing this twice. H heap. While C. So it's trying to free a void null pointer. I'm not sure why. Is there something about the implementation that I missed or use? Renders into bitmap you provide. Bake font bitmap. I don't really know. Like, why would this... This is... What are you talking about? Is it's doing? I feel like it's doing something weird. So this technically is actually minus bitmap x, right? So now it works just because of this. So it's doing something weird with the length. I don't know if it's like clearing something out later. Oh. So I am on I equals 17. Our current X position is 244. The width is 257. So why didn't we advance it? Oh, we're on the second line, but I never reset the bitmap X. I, yep. No. Same one. So we run all the way here. We notice, oh, actually, 244 plus 13 is more than 256. So new X is 1. I see. Bitmap Y. So we're also starting 1 pixel off the stride. Plus equals largest height plus 1. Now we are starting from the beginning every time. So That is correct. And then this thing is minus bitmap y. Now it should work. There's still an issue. Let's see. Let's break in our draw. Right. Now, okay. So let's analyze this a little bit. So we are drawing A, but then we're not advancing down. There's something is going on here because this is R. R is like the 17th character or something, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then R is the 18th character. And what we were seeing was that here do you know what? I think what it's doing, it's like clearing everything around it, and I don't want it to do that. So probably what I need to do is instead of putting in the texture texture size here, I'm just gonna literally plug in the width and the height as it is. And that does, it has a similar issue, but not quite the same. You can see R here is actually, you can actually see what's going on. Like you can see R much better. Here it's cut off. But very clearly the characters are drawn on top of each other. And for some reason here, 4 is down there. The first character in that row, but then the rest are from the top. So how is that happening? I see what's going on. So this should be there actually. And like that. Yeah. There we go. So now we have a something, right? Now you will notice they don't look aligned. So this A looks way higher than the B, and the C looks way higher than the D. That is, and yeah, the G is supposed to be lower and the H is supposed to be higher. It's because it has this like, you have this like base square that all of them are fitting within. There, there. And then you have these extenders. This is extending, this is extending. This doesn't have an extender, so like, this is extending, this is no extending. This is the base, and then here's it's extending. This is the base, and it's extending. So all of these characters have sort of like a placement when you try to use them. Also, some characters don't exist apparently. So Euro doesn't exist, which makes me sad. Maybe it's only the Euro. Carat, percent, dollar, and then Euro. But the Euro might be, 3 bytes. What is it actually? Yeah, the Euro is 3 bytes. Not character, but U8. No? So this is the dollar sign, I think. And then you have this, which is this is the Euro sign. So that's why you get three X's there. It doesn't know what it is, which, whatever. Speaking of, alphabet. Yeah. So like this is 3 bytes. It wouldn't if it's a Euro sign. But I think the nice thing, like it would just work if I would just read it like that and then use it. I think maybe not. Maybe not. It's fine though. It's fine. Or I just add it as a U32. Or was it main? Okay. Now if I actually want to use this, I need to calculate the UVs. And not only do I need to calculate the UVs, I need to calculate the position of the characters in relation to each other. Also, one thing I forget, if this doesn't fit, so like, let's say we do something like that. No, it for sure doesn't fit. What happens then? We get a, access violation location thing. Now, can we detect that? Load assets. I equals 13. So we run out of space, I'm pretty sure. Yeah, the Y is not large enough for the height. Because 61 plus 18 is definitely larger than 64. So if that happens at any point, what we need to do is we need to double the height and re-render. So it happened here, yes. We calculated the bitmap Y, but we do know the next height. So next width, right? But we can do also next height. Though that could be... do I really need to go through all of the characters and see the tallest one? If I want to be super safe, then yes. Because like, imagine this is a dot, right? The height is going to be super small. Then the third, the character after that is, the character H. And then that's super large. I could find the largest encountered. Then I don't really like just the largest encountered so far. And I do the same thing as here. But I do it before that. Largest encountered. Um, we have that. We get we don't need the next height. but we can say if basically the same thing as here, but with the height. If the bitmap y plus the largest encountered is larger than the side length, then oh my god, we have to double the height of the bitmap. Then this I can't use the same. This has to be X and Y. So we start with that. But then we start to use each individual one. Stride is the X. Here it's also the X. If that is the Y, bind texture, it's X and Y, whatever we end up with. So yes, okay, we have to double the height here, which means we have to do the same thing that we were doing before. And maybe this will be a function, I'm not sure. Let's do this for now. Okay, this is kind of a is a constant about the picture, so I do need that outside. The total is not important. Bitmap is a constant. So again, I do the same thing. It can be this I don't need. Total bitmap, new bitmap, right? It doesn't need to be, or should it? Probably it should be callocked, right? Then we do mem copy the bitmap. Now this destination is new bitmap. From bitmap size. Well, it's this size, right? This one. Okay, so we copy that. We assign the new size Y. Actually, we That's the simplest way I can do it. I can clean it up later maybe, but like, okay, so we have a new total with a double size Y. That's a new bitmap. We copy from the old to the new. We assign. Well, I need a buffer. A temp. So this is just saving the old bitmap somewhere, assigning it to the new size, and freeing the bitmap that was created before because we need to make a copy and copy it over. I don't have the option of just expanding it or like realloc. Maybe I should just do this. And it does this copy for me, right? Does it make everything, does it clear everything after? Like why doesn't it say realloc new memory is 0 or what? Okay, you need to do your own. Yeah, let's not do realloc. Doesn't seem very useful in this situation. Like this is just simple enough. I want it to be 0 initialized because I'm making a buffer for a texture. So I think this is just the best solution, honestly. Like allocate a new one, copy the old data in there, and free the old buffer, and reassign it, and that's it. And then double that. So now it should work. And technically, this can actually trigger multiple times. You see, that just works now, and I think that actually did trigger multiple times. Let's take a look. Yep, twice, 3 times, and then what is the bitmap size Y? 512. So that divided by 4. Whoops. Did it trigger 5? No. Divided by, so once is 2, 4, 8. 2, 4, 8. So 3 times it triggered, and that's what you get. That is beautiful. Even better than I thought. It doesn't really matter that it's copying the memory because the memory is 100 kilobytes anyway, at least for this size. But that's only like that shouldn't it should never even trigger at all. I just overrode that for testing. So yeah, now we are creating the texture. It's time to try to draw it. Now, whenever I draw it, I need to, well, I need to have the UVs. So I should calculate the UVs somewhere. Well, so here's the issue, right? If I make this larger, I have to recalculate all the UVs at the end if I'm doing it during this loop. So I'm gonna wait until I finish drawing all of the characters, and then we do another, for loop. I30 to I equals 0. What was it? Alphabet? No. Alphabet length. Yeah. So when we reach this point, we have the character array with the sizes. We need to calculate the UVs using that. Do I log the position? And this can actually be float. But I will not normalize. I will normalize it in a loop later. But when I'm setting them, I will just record the position. So we make this code point and we say C position equals the bitmap X. Same for Y. They are just cast to float. I guess that's implicit, but why not? And it's going to be, in the low hundreds, maybe thousands. So there's no way this is going to be an issue casting it to floats. And then here again, in my for loop, I look at the total size of the bitmap. And remember, this is from the top left corner. Character chars. Right. Yeah. Characters. And then we say the C. Equal divide equals bitmap size X. Right. Same for Y. So I can use that to calculate all the UVs. I'm just thinking a little bit right now because if I have a vertex, I have the position of the vertex, and I have the UV, like for the texture for the position of the vertex. And then we have something like the color, maybe. For font, that might make sense. The thing is, I need to generate this on the fly now. Now, obviously, the projection into the world is one thing. The translation and the, everything. And it's a little bit harder than I was thinking about, because, like, okay, let's say we have a single. This is our character block. In here, you might have A, or you might have a G. And notice that if I put them next to each other like this, I have to draw the A up there in order for the G to be aligned. Yes. I can't draw them both from the bottom, because then it's going to be offset. But now the issue is, if I draw this A like this is all, like, the A is going to be stretched like that if I make it like that. Because otherwise I'm going to have my A over there, and then whatever is below, this R is going to bleed into that, for the UVs to be correct. So I can't have, or it would be like difficult, it would waste space. I would have to make this like mono spaced somehow in the buffer. So I don't think this is a good solution. Instead, I have, my, if I have some baseline, like that, I have my A, it's placed like that. Then I have my G, it's placed like this. And now it fills it completely, and it fills it completely. But then all of these vertices needs to be calculated on the fly. And another thing that I forgot to mention is that if I have this is basically monospaced. So it means that, I have, here's an A, maybe that's fine. But then I have I is going to look like that. And instead of having this proper, the proper distance between them here, it's going to be always some, like, it's going to be dependent. Like, imagine that I have two eyes. They're going to be super far apart compared to, like, two A's. Now, just tiny space apart. So I really need to, make sort of a vertex for each one individually. Alternatively, I can draw them all into a no. No, okay. It's not a good idea actually. Uh so what I was thinking about was I could make a large buffer like this and then I just like draw into this buffer separately. And well, that would be possible if I would make another buffer. Like it would be feasible for me to do that if I draw everything into a separate buffer on the graphics card. And then I just use that texture finished and composite it on top of the rest. That would make sense. Otherwise, it's basically software rendering the text for no reason. And that doesn't make sense. The benefit with that would be that every time you draw a character, it stays. So I can just save the texture. I can draw another character. Like, let's say I want to have this effect of, it's being typed out. Then every frame I could just draw another character or two. And I don't have to redraw them later. So that would be one benefit with having one buffer like that. Otherwise, you're just, one frame you're drawing one character, the next frame you're drawing two characters, the next frame you're drawing three characters, but it's the same characters in the same spots. So it's kind of like wasting space. So what would I like to do? I think I need two systems. I think I need one system where I have this like big buffer that is like stored on the GPU while it's being displayed, so I don't have to redraw it with hundreds of tiny rectangles all the time. But that would be using the same system that I would have generally, which would be, I'm calculating a bunch of squares or rectangles like this on the fly. Because, like, let's say I have a frame counter. No, I need to have this system where I make vertices for all of them. So how would I make that? Let's start. Like, it would be nice if I could just have the position of each. So, like, here's the thing. Okay, this is what I'm thinking. If I would just have a perfect square and I would set those up for all the characters individually. So this A is going to be stretched, like very wide, very fat. The G is going to be too high up and, stretched also. The I is going to be looking like a big boy, like that. Uh, then I still have to, correct it later, possibly every frame. I have to move this down and scale it down like this. this eye, I have to do it like that to make it look fine. So it would be much nicer if, you know, I would have, this is the finished box, this is the finished box, this is the finished box, and this is A, G, I, and all I'm doing is I'm reading the distance from one character to the other, which I think was the it was given by the, like, this offset X, right? I think that's what that is giving me. So that means calculating this correctly and generating the vertices. I don't want to have, I want to have vertices with only position and UV. I'm not going to include color. The color is going to be one static variable. Is uni something uniform variable. I can do that. U34. Okay, so how do I calculate that for the A? Well, the UV is, well, okay. This is a fat vertex because it's having more things than I need. I need multiple variations of this vertex if I want to skip having the color. So that was in game vertex. So I can have a really, the position is V2. I think that should be V3, but okay. That's what a vertex is. Then I have vertex with a vertice or do I just have multiple structs? This is a like hard design question. I don't have a good answer for that right now. For now, I'm gonna keep it as V2. I'm gonna add the third dimension eventually. Okay. I need a short break, so I'll be right back. We have a guest. Mishu, hutch. Hop. Oi. Hopla. Oh, yo, yo. No fighting. She came up to me when I came back, and then she started fighting immediately with her brother. Huh? Okay. Yeah. All right. So what was I talking about? Yes, these vertices. I need to add them to the character. So actually, let's. That is not very interesting. Vertex UV. Yeah. And I need 4 of them, right? If I keep the same thing as here, I can use the same indices for every rectangle like that. But yeah, I need to generate those 4. So what would that be? It would be CX VX vertexes. Let's just type it out. So we have the first vertex, the position. Now I have to look up what these values actually mean in practice. Hmm. I can do something about that. The game. Okay, let's put them closer together. So if we look at the first vertex here, this is the bottom left. Yeah. The top left is the last vertex. This is counting from the bottom. So I can say, I can immediately calculate the UVs. For all of them, actually. Zero. So this was bottom left. Like that. And what is this? The bottom left is the bitmap X comma the bitmap Y plus the height. Checks out. The bottom right is the same thing, but plus the width. Oops. Let's do this instead. Now it will be clear. Top right is this. Top left is this. And when we later go through this, we do all of these things, dot UV. X divided by the width. The bitmap total size X divided by Y. Array count. See vertexes. Yeah. And we do that for all of them. Okay. I was scared I made a typo there. So that, I think that's the vertexes sorted. And then just for testing, we can try to use them. Oops. How do I... So these need to be adjusted. The kerning of the character in question. But these are just squares. Yep. Um, now I could. I need to write another shader, I think, in order to not have the color. Texture. Actually, no, because I'm just ignoring it. Well, it's the vertex buffer that has the stride, right? I believe so. Okay. So to test this, I don't want, like, I need to use the regular vertex for now. Because I need to generalize this to make it work. Yeah. So now it's going to complain. Let's use normal vertex. Now, are each character its own vertex? Or are all the characters together one big vertex blob? And then I can... Because, okay, I could bind one vertex array like this with one and reuse the indices, you know? I could do that, or what I could do is I could make a bunch of vertexes in one array. Then each character, it's 6 indices, and then just like multiply the position of that character with 6, and then I get the indices in the vertex array. I think that's the way I want to do it. Yes. So I can just generate all of that. So after I do this, the texture can actually go up here. So we have our number of characters. The size is the same one as before. Such a good song. I know you can't hear it, but man, trust me. So when we do this, we generate all of the vertices. Then we need to store them in one buffer. And like this will fit on the stack, but maybe it should be allocated. I should have like a scratch buffer. How large might this be? So let's say the average vertex is V3. So that's, but floats, not doubles. So it's 4 times 3. Plus 4 times the UVs. Plus 4 times 3 for normals. And then we have, let's do just like this. I know you can barely see what I'm typing. Here we go. That's better, right? So 4 bytes is a typical float. And then we have the position in 3 dimensions plus the UVs plus normals plus bump map, so another UV. Or maybe they will be shared. Oh, I think that's like, let's add color there. Just because. So RGBA color in floats. Because why not? So that the average vertex is going to be 48 bytes large. And then how large is the average alphabet? It's 4 vertices times, say, 200 characters, just to be like very like overestimated. That's not that many bytes. It's like 3 kilobytes, 40 kilobytes. And if I would do the same, 48, but now I have a very big normal. Let's say I have a huge model, and the model is like 50,000 vertices. Then that's still under 3 megabytes. So I can have a scratch buffer of 10 megabytes. Like a work buffer of 10 megabytes. What was this data? Is that my load read buffer? Yeah, that's already my scratch buffer. But I didn't. I do have used. Okay. So I forget about making this. I can just use this, I'm pretty sure. So this equals vertex data state data no assets. Where is this? No, it's separate from anything. Uh-huh. I don't know. I should probably move that later. But I am passing it in, right? Assets here. Times character length. What was it? Times 4 vertices per character. Yep. And we also need a int 32, u32, indices, ibuff, u32 star. Size of u32 times that times 6 actually. And then we do for every character. VBuff I dot. Well, I guess we have to. Can I do this because it's a v2? Just copy it. C vertexes. Well, it would be 0. So this is plus 0. 1, 2, 3. And I times 4. So I can do that over here. I32 v vertexes per character equals 4. And similarly, indices per character equals 6. So then it becomes very clear. And similarly for the indices, iBuff, indices, they follow the pattern 0, 1, 2, 0, 2, 3. So it's 0 plus I times the indices, right? I think that makes sense. So this is 1, 2, 3, 4, 5. 1, 2, 0, 2, whoops. 2, 3. I think that makes a lot of sense. Then we have to create those buffers. Now, I don't have a very good... I have create shader entity. Can I just throw that in here? It's not really an entity in that sense. Because an entity in the game, well, I mean, it has a mesh. And then you have, rotation and, well, momentum should probably not be there. I can have velocity later, but so it's a mesh for sure. But I feel like I shouldn't make an entity. I should make it a mesh. So I need this function probably needs to take a mesh instead of an entity. And then the entity can point to a mesh. I think that makes the most sense. But then I have to change all of this, how this is working. And this shader entity should not be a shader entity. It should be a mesh. Shader mesh. Oops. There we go. Yes, shader entity, no more. Shader mesh. Now this is kind of a dramatic change right at the end because I'm not gonna keep going for not more than an hour, preferably less, maybe half an hour. Shader meshes. This is different now. Mesh max. And that can be also, 32 for now. Let's say the entity max. Why not? Meshes max. There we go. Shader meshes. Now it's going to be complaining. So shader mesh SM. This is all the same. Like mostly. Now the game has the vertex data right there. I don't think that makes a lot of sense. I feel like this should be just a void pointer, and that should be part of the graphics library or graphics header. Because all these things, they should just be in here, right? And then this is a void. I think structurally that makes more sense. Now, of course, I can't just do this because it's a void. But those things shouldn't even be assigned here. Is my point. Like all of this should be E0 dot mesh equals and then I can have I can have a I can have an enum. And this enum is meshes. And we have a triangle. We have mesh rectangle. And we have mesh alphabet or something like that. Based on that, I can request from the... I want to be able to request a like GFX. And this is also void. I need a way to call a function that says, I want to load this mesh. And if it's not loaded, please put it in memory somehow. So I'm going to try something, okay? I'm going to just take... I'm just going to put in here void star graphics request mesh. And then in my main, actually, first in OpenGL, I have my draw there. I return something like, well, it also needs to have a void star graphics. Should it have states? I'm not sure. Because the graphics... It needs the state. Because if I need to request, if I need to create the mesh, it means I need the state probably to set that up. So I will go back. Where was it? Game H. This should probably not be here, by the way, also. It's too annoying to go to OS and then graphics and blah, blah, blah. It doesn't know what the state is. Mm-hmm. So whatever. Void state. That's okay. Mm. OS, well, so the graphics has the shader meshes, and I'm gonna just return. And that also means that probably this should not be in one continuous array with all the meshes in the game. It should just be. I should find the mesh if it's there, and then if it's not, make it. But that's for the future. Right now, as long as I can get the requested mesh, I am happy. os dot request mesh state and mesh ID mesh. I want the triangle. And for this one, rectangle. Now that's going to have huge issues still. Graphics has no idea what's going on. Create shader mesh. I was in the middle of. Oh, wait. So what? They're the one and the same right now. So this is assuming that it's already created. I need here. I'm loading my assets. So the first thing I should do is probably set the first shader meshes up. They are called primitives. Triangle was the first one. Yep. Actually, I can just do mesh triangle. Not the program. The things I set up here. So vertexes. Let's try. That's an array. It's a little bit of a big change right before being done, but I will try to finish it. Shader mesh. So all these things specific to the GPU. This is the raw data. I might split that up again later, but then I have a mesh for the main, like an abstracted mesh for setting up, and then the actual shader mesh that is specific to the GPU API implementation. So the vertexes are the try. Where is that coming from now? Because I need this somewhere it can see it, but I don't want it to be in everything. If I define it in here, it does work if I then immediately call the create. So that does actually work. Yeah, vertexes. Then indices. And then we have this. Mm-hmm. And then we do the same thing for the rectangle. And where did I create shader mesh? Oh. I called it here, which was after After the shader, obviously, yeah. But does it actually... So I'm calling it was setup and then load assets. Yeah. So here, what I actually need to do, I need to call this function. It's called shader mesh. It's the graphics shader meshes mesh triangle. That doesn't exist anymore. And then the shader program. The shader program I have to just choose right now. And then I do the same thing for the rectangle. And I think that was using the second program. And that was what my override was doing as well. Shader mesh, E mesh v count. It's actually the SM mesh count. Or it's not in shader entities, it's in shader meshes. Does that work? It's the shader mesh. Well, I have the entity, but I also have the shader. Right? I'm scared to test this. Yeah, yeah, yeah. Um, well, that's never. That's a void. It's a null function pointer. Breakpoint. No. Why? You don't like me. That's why. Um, Unable to read process memory. Really? Did I not? I did that. It's a character. So what is going on here? Chars. We have a bunch of chars, like 80 of them almost. The address for C on right now we're at oh well that makes sense. Man, the typos you make sometimes. Another breakpoint. No. Assertion failed. I don't know what the issue is. And I'm a little bit too tired to dig too much into it. I can go into. Oh, probably they're never assigned entities. I think this is like just 0 or something. So we have these entity. This is going to be a pointer to a mesh. It has. This is not valid. Which makes sense. Because this is just random. Like, okay. When I go off scope here, I go down there. From here to there. This is no longer in scope. This is free game for the stack to replace with whatever. But that's fine because I create the shader mesh within the scope. So all the other things, v count, I count, they look good. Vertex buffer, vertex array, element buffer. I think those are also okay. Shader program number 4. It has. It shouldn't have a texture. Why does that have a texture actually? I think it's being overridden somewhere. In the setup. We compile the shader and another one, and then we return. Bind texture, blah, blah, blah. So why would that be? I have to look at the, like, from the beginning here. Let's take a look at this function pointer that I made also here. Where was it? Not check error. This one. Okay. But that's fine. It's not initialized. But it will be, and the pointer is the same. This shader mesh shouldn't even have those. Mm-hmm. That's a static, so it doesn't matter. First one was vertexes. Next was size of vertex. And then we have indices, which is rect indices. And we get rid of that. No more dangling pointers. And we do the same, but for triangles here. No member. Okay. Seems all right. It's not drawing. There's two of them. Oh. This is a null pointer. Where did I assign that? I completely forget. And this texture. I never assign it. So when should I assign it? Where even is it right now? Shader mesh? I guess so. So I'm just gonna say this rectangle and dot color texture equals 0th. No, graphics. I got it working again. But I'm not drawing this at all. But that's gonna have to be it for today. What I will be doing next time is obviously we are generating a bunch of vertices or vertexes here. So to do, these vertexes should be adjusted to fit the character better. So that's what I want to do next time. Try to draw this and then readjust these to be fitting the character, like I was discussing with his paints, like right here. But that's it for today. Let's push. Hello? It's not? Okay. Oh. Please? Maybe? Why is it not working? Like, I don't get it. Um, we are writing all characters requested into a buffer that scales if needed. Okay. We are done. So thank you all for watching, and I will see you after the weekend. That was a pretty productive day. I feel happy about that. So yeah. See ya.